Alright, so we'll start problem solving session of week 6. Welcome to the sessions. My name is Shreya and I'm one of the TAs for this course on Introduction to Probability and Statistics. So today I'll be discussing a few sums on the concepts that we have learned so far, and if you have any doubts, you can post it in the discussion forum below. But before moving on, I would like to brush up on the concepts that we have learned so far and then proceed further. So in this week, what we learned was functions of several random variables. We learned how to formulate distributions of functions of several random variables. We learned a little bit about order statistics. So in the last class I did one sum on the minimum and maximum of a random variable. So that is nothing but that comes under the domain of order statistics. And then we have also learned a little bit about how to find out conditional distributions and random sums. So to find out certain important distributions of certain transformations, a few of the important results were stated as given over here. So if xy represent a two-dimensional continuous type random variables, so random vector in 2D space, then the joint PDF, if it is given by fxy xy, then if the form of the PDF can be written in terms of, if we want to transform the existing y and z into another 2D space with z and x or z and y, then the sum can be written as in this manner. Okay, and if we want the difference, then we can write the PDF directly in this form, fxy u plus yy dy. If we want the product of the two random variables, then we can use this form of the function, and if we want the ratio, then we can write it in this fashion. Okay, up next we learned about the definition of we learned how to define a conditional random variable. So if we have two discrete type random variables, then the conditional probability mass function of x given y equal to y is defined in this manner, similar to what we have studied so far in probability. So x given y would be the intersection of x and y by probability of y. That is essentially what has been this is not conditional random variable, this is conditional probability mass function. Okay, so we can write it in this form. If we have, this is a mass function, that means for two discrete random variables. Now similarly, if we have two continuous random variables, then this will be called conditional probability density function, and this definition that has been stated here would hold true for two continuous random variables. Essentially the same thing, the joint distribution of x and y divided by the marginal of y. Okay, And then we defined what we mean by order statistics. So X ordered K of a set of random variables is that how are we defining it, the kth order statistics? So we arrange the values of X in ascending or descending order, usually in ascending order. So then the kth value is known as the kth order statistic. And then we also learned that if the random variables, if we have, let's say, n random variables, and those n random variables are IID, then the joint PDF of n continuous order statistics is given in this manner: n factorial into product of fxi into xi, where fxi is the individual PDFs of the order statistics. And also we learned how to find out the marginal PDF of the rth order statistic given the CDF, the joint CDF, and the not the joint CDF, but since this is IID, that is the common CDF and common PDF of the n random variables. So this theorem essentially gives us the marginal PDF of X order R, that is the rth order, I'll write it in this manner, rth order statistic when x1, x2 xn are IID random variables. IID means they are independent and they have the same distribution, that is they are identically distributed. Okay, so with these definitions and a few solved examples were also solved by sir during the week 6 lectures. So with this context, I am going to hop on to some of the problems which will help you solve the assignment questions. Alright, so let's get started. So this is the first question, that we are given a random variable with PDF these, and we have to find out the joint PDF of y equal to 8x cube. Okay, how are we going to find it? So yeah, so let's start with how should we proceed if we are given something like this. Alright, so given that we have a random variable with PDF fx equal to 2x, where x can range from 0 to 1, we have to find out the PDF of y equal to 8x cube. Now, if we have something like this, what we can do is PDF of a new distribution, I'll write it in this manner. PDF of y can be written as PDF of x in terms of y into the Jacobian. Okay, so what is determinant? This is what? This is determinant of the Jacobian. So this J, so what is this J? J is nothing but, so here we have 1. This is D old by D new. Okay, so here this will be D of x by D of y. Now with this, if we have to write it down, how will we do it? So now we know how to write PDF y in terms of the PDF of x when this is a, let's say, so now Fy, so let us find out the Jacobian what it is. So for a single univariate case, this is nothing but dx plus dy, that is 1 by dy by dx. Now here y equal to 8x cube. Alright, then x can be written as y by 8 to the power 1 by 3. Okay, and from here we can write dy dx equals to 8 into 3, 3 will come down, x square, that is 24x square. So this one we can write as 1 by dy dx is 24 and x is y by 8 to the power 1 by 3. So we'll have y by 8 to the power 2 by 3. So this 8 can be written as 1 by 24 y to the power 2 by 3 by 2 to the power 2 by 3. Sorry, 8 to the power 2 by 3. So 8 can be written as 2 cube, this 3 cancels, then 2 square is 4. So we'll have 1 by 24 into y to the power 2 by 3 by 4. So we'll have 1 by 6, or we can write it in this manner, we can write it as 1 by 6 y to the power minus 2 by 3. So therefore, if we have this, then f of y will be equal to f of what I wrote, x in terms of y into the determinant of Jacobian if it is more than 1, or the absolute value of the Jacobian. Okay, so here in case of two variables also, this will be absolute value of the Jacobian. Jacobian itself is the determinant. For a single variable case, we don't need it. Okay, so x in terms of y. So here what was it? It was fx equal to 2x. We had fx equal to 2x for 0 less than x less than 1. This was our function. So now we can write it as fx equal to 2, and now we have x equal to y by 8 to the power 1 by 3. So we can write it as y by 8 to the power 1 by 3 into, this thing is, this can be written as 1 by 6 y to the power minus 2 by 3. This can be written as 1 by 6 into y to the power minus 2 by 3. This 2 and this 8 to the power 1 by 3 will cancel. So we will be left with 1 by 6 y to the power minus 1 by 3. So therefore fy equals to 1 by 6 y to the power minus 1 by 3. Now the question is, range of y will be how much? If x ranges from 0 to 1 and y equal to 8x cube, then y can range from 0 to 8. So this will be the distribution of y. 1 by 6 e to the power minus 1 by 3, where y ranges from 0 to 8. Okay, so next we'll move on to the next sum. Here we have been given that y is a continuous random variable, and this is the PDF of y, and we have to find out the probability y less than equal to 2 by 3 given y greater than 1 by 3. So by definition of conditional probability, we can write probability y less than equal to 2 by 3 given y greater than 1 by 3. This is probability y less than equal to 2 by 3 and y greater than 1 by 3 divided by probability y greater than 1 by 3. So this thing we can write as probability 1 by 3 less than y less than equal to 2 by 3 by probability y greater than 1 by 3. We can write it in this manner. So now we have to evaluate the individual probabilities. So probability 1 by 3 less than y less than equal to 2/3. Since this is a continuous random variable, we don't need to bother much. It will be 1 by 3 to 2 by 3 into fy dy. What was fy dy? Fy dy was 5y cube. So here we would have 1 by 3 to 2 by 3, 5y cube dy. One thing to note is that y ranges from 0 to 1. So 2 by 3 is less than 1, 1 by 3 is also less than 1 and greater than 0. So it falls within y's range. Okay. So this will be 5y to the power 4 by 4, 1 by 3 to 2 by 3. This will be 5 by 4, 2 by 3 to the power 4 minus 1 by 3 to the power 4. Okay, let it be like this. So now we have the numerator figure that is there. Next we want the denominator, that is probability y greater than 1/3. So probability y greater than 1/3 would be, the range of y is from 1/3 to 1, since y can range from 0 to 1 only. Okay, so it will be 1/3 to 1, 5y cube dy. So here again we'll have 5y to the power 4 by 4, 1 by 3 to 1. Okay, here I am writing it. We should write it as this 5 by 4. So here also we have 5y to the power 4 by 4 1. So this will be written as 5 by 4 1 to the power 4 by 4 minus 1 by 3 to the power to the power 4. Okay, therefore required probability will be probability 1/3 less than y less than equal to 2/3 by probability y greater than 1/3, that is 5 by 4. We had 2 by 3 to the power 4 minus 1 by 3 to the power 4 divided by, here we have 5 by 4, 1 to the power 4 minus 1 by 3 to the power 4. Solving, we'll have 5 by 4 will cancel. We'll have 2 to the power 4 minus 1 to the power 4 by 3 to the power 4 minus 1 to the power 4. So this will be 16 minus 1 by 81 minus 1, that is 15 by 80. How much does it come to? 15 by 80, this will be 0.1875. Alright. Okay. Fine. Now we'll move on to the next one. So this is the answer. This is how we would find out conditional probability distribution. Okay. Let us consider this one. So here we have a continuous density function given by this thing, where a and b are unknown. Now we have to find out what are the values of a and b. So here we have two unknown parameters. So we should have two independent equations in order to get unique values of these two unknown constants. Okay. So the first thing is, given that this is a probability density function, then if we integration minus infinity to infinity, fx dx should be equal to 1, since f is a probability density function. Okay, so here what does this imply? It implies that x ranges from 0 to 1, fx dx should be equal to 1, which implies 0 to 1 alpha plus beta x square dx should be equal to 1. Then we can write this as 0 implies 0 to 1 alpha plus beta x was the value, right? Alpha plus beta x square, dx equal to 1. So we can write it as alpha x plus beta x is cube by cube, 0 to 1 equals to 1. So this one implies that alpha plus beta by 3 equal to 1. Let this be our equation 1. Okay. Now, next what we have been given? We have been given the expected value of x. So, given that expected value of x equal to 3 by 5, this is given to us, which implies that x fx dx, this should be equal to 3 by 5, which implies 0 to 1 x into alpha plus beta x square this will be square dx equals to 3 by 5. So we can write it as 0 to 1 alpha x plus beta x cube dx equals to 3 by 5. So then we can write it as alpha x square by 2 plus beta x to the power 4 by 4, 0 to 1 equals to 3 by 5. So that implies alpha x square by 2 plus beta x to the power 4 by 4, 0 to 1 equal to 3 by 5. So it implies alpha by 2 plus beta by 4 equals to 3 by 5, or 2 alpha plus beta equals to 12 by 5. This is my equation 2. And equation 1 was alpha plus beta by 3 equal to 1. Alpha plus beta by 3 equal to 1, which implies 2 alpha. This was my equation 1. 2 alpha plus 2 beta by 3 equals to 2. Let this be my equation 3. So now subtracting equation 3 from equation 2, we have 2 alpha plus beta minus 2 alpha plus 2 by 3 beta equals to 12 by 5 minus 2. So here 2 alpha cancels. Beta by 3 equals to 2 by 5, which implies beta equal to 6 by 5. Therefore, alpha equals to 1 minus beta by 3. 1 minus beta by 3. 1 minus 6 by 5 by 3 equals to 1 minus, this is not square, equal to 1 minus 2 by 5, that is 3 by 5. So the answer is alpha equals to 3 by 5 and beta equal to 6 by 5. That is option C. Okay. So let's move on to the next one. Alright, so here let x and y be continuous random variables with joint PDF given by this. Then what is the marginal distribution of y? So the first thing that I would want you to notice over here is this xy term. Okay, so you could directly use the formula listed over here to get the distribution of v. Okay, but I would rather insist on working at things out properly, so that even if faced with some difficult situation, you don't have to remember these kind of transformations. So I'll just show you how to go about these kind of things. Then it'll not be like memorizing. You'll be able to write logically. Okay. So here we have a product term which involves both x and y. Now it's a little difficult to work around with product terms, because if we had to find out the marginal distribution of y, since the x over here cannot be separated from this y, it becomes a little challenging. So what we'll do is that we will transform this xy variable, we'll transform to another random vector in the 2D space, uv. Okay. Now what will be the form of the transformation? So let's say u equals to xy and v equals to, what do we need? The marginal of y, right? So let v equals to y. Let us define u equals to x by y and v equals to y. Okay. So now for this sort of a transformation uv, I already told you about the Jacobian, right? So let us find out what the Jacobian of this transformation will be. So Jacobian essentially means determinant of del old by del new. Okay, so it can be written as, so this is not the official thing to write, you should write it in this manner. So this is del uv by del x, del uv by del y, sorry, this one this should be written as del u by del x, del v by del x into del u by del y and del v by del y. U equal to xy, v equal to y. So this can be written as, this will be del old by del new, na? So I can write it as 1 by Jacobian equals to, okay, so I'll write it afresh over here. Jacobian is del old by del new determinant. Okay, so here what I am writing is 1 by j, that is del new by del old. Okay, so essentially I am writing 1 by j over here, that is del u by del x, del v by del x, del u by del y, del v by del y. So del u by del x will be y, del v by del x will be 0, del u by del y will be x, and del v by del y will be 1. So the determinant is y, or we can write it as v, because everything we will be writing in terms of u and v. So let me write 1 by Jacobian is v. Then this mod of this is the absolute value. Okay, so absolute Jacobian will be 1 by v. Okay, so now then f uv can be written as f xy in terms of uv, okay, and into the absolute value of Jacobian. Okay, so this one was what? This one was, so fxy, if I can write it over here, fxy xy was 1 by 5 y e to the power minus xy, y e to the power minus xy. So this we'll write in terms of u equal to xy, v equal to y. Okay, so this one we'll write, this will be 1 by 5, instead of y we'll write v, e to the power minus u xy into the Jacobian was how much? Jacobian was 1 by v. 1 by v. So it will be 1 by 5 e to the power minus u. And what will be the question is ranges. This is very important. We cannot forget the range. So here the range was x belongs to 0 to infinity, y belongs to 1 to 5. So what will be the ranges? We got the formula. Now x belonging to 0 to infinity, y belonging to closed 1 comma 5. So then xy can belong to 0 to infinity. Whatever you multiply, it can take on value 0. If x is 0, xy, whatever be y, it will be 0. And if x is infinity, whatever be y, that will also be infinity. So which implies u can range from 0 to infinity. And v equal to y, which implies v belongs to closed 1 comma 5. So therefore the joint PDF of u and v is given by f of uv, u comma v equals to 1 by 5 e to the power minus u when u belongs to 0 to infinity and v belongs to 1 closed 1 5 and 0 otherwise. So now we have the joint PDF of u and v. Now we have to find the distribution of y, or we can write it as v because v is essentially y. So how? So then f of y is essentially f of v, which can be written as f of uv over the range of u. Is it okay? So then this will be 1 by 5 e to the power minus u, and u can range from, we have written 0 to infinity. 0 to infinity. Okay. So this will be 1 by 5 e to the power minus u minus 1, 0 to infinity, 1 by 5, 0 minus of minus 1, that is 1 by 5. Okay. So when does this hold? When v will range from 1 to 5. Okay. Therefore, the marginal of y, or in other words v, is given like this. f of VV equals to 1 by 5 given V belongs to close 1 5 and 0 otherwise. Okay, so essentially the marginal distribution of y is this one. I hope this is clear. Fine. Then we'll move on to the next one. Alright. So this question says that suppose that we have a number of customers visiting a fast food restaurant in a given day is n, and this n is a random variable which follows a Poisson lambda. Assuming that each customer purchases a drink with probability p independently from other customers and independently from the value of n. So let x be the number of customers who purchase drinks. Let y be the number of customers that do not purchase drinks, so that x and x plus y, they add up to n. Now we have to find out the marginal PMFs of x and y and the joint PMF of x and y. We have to find out whether they are independent or not, and based on our conclusions, we have to find out whether what is the value of expectation of x square y square. So here we assume, so x equal to number of customers who purchase drinks, okay, and y is number of customers who do not purchase drinks. Now in each day, in a given day, n customers arrive, okay. Therefore x given n equal to n customers have arrived in a particular day and they have purchased drinks follows a binomial NP. Out of the n customers, you could, this is like probability of success and probability of failure. So success is purchase of drinks. Given that n customers have arrived at a day, condition on n, x follows a binomial NP, probability of purchase of drink, probability of success. Similarly, y given n equal to n, this follows binomial n 1 minus p, because why is that? The customers do not follow these many number of drinks, okay. So, and also we have to find out that x plus y is n. So now, given this formulation, the marginal PMF of x is given by probability x equal to k, let's say. So we can write it as probability summation probability x equal to k given n equal to n into probability n equal to n, where n can range from 0 to infinity. This can this can be written by law of total probability. Okay, so then x given k, x equal to k given n equal to n, probability n equal to n. So now we have x given n follows binomial np. So we can write it as summation n ck p to the power k 1 minus p to the power n minus k and the n probability n equal to n follows a Poisson lambda. So this can be written e to the power minus lambda to the power n by n factorial. Alright, and this thing can range from n equal to k to infinity. Okay, because otherwise this thing is not defined. Alright, why? Because n, at least k customers should, this n minus k cannot be negative. So this range will change from 0 to k to infinity. Alright, now if we break it up, this nck we can write as n factorial by k factorial by n minus k factorial p to the power k 1 minus p to the power n minus k e to the power minus lambda to the power n by n factorial. N factorial we are cancelling out. So this thing we can write as summation n equal to k to infinity 1 by k factorial n minus k factorial into p to the power k 1 minus p to the power n minus k e to the power minus lambda to the power n. Okay, so we can take the k terms without involving n out. So we can write at e to the power minus lambda p to the power k by k factorial summation n equal to k to infinity 1 minus p to the power n minus k divided by n minus k factorial into lambda to the power n. Okay, so this one we can write as e to the power minus lambda p to the power k by k factorial summation n equal to k to infinity 1 minus p to the power n minus k. Lambda we can write as lambda to the power k into lambda to the power n minus k by n minus k factorial. This lambda to the power k will take it out. So lambda to the power k and p to the power k will have e to the power minus lambda p whole to the power k by k factorial summation n equal to k to infinity lambda into 1 minus p whole to the power n minus k by n minus k factorial. Now let us write n minus k equal to some z. So we'll have here e to the power minus lambda p to the power k by k factorial summation. What did we had? N equal to k to infinity. I'll write it again here. Lambda p into 1 minus p. Sorry. Lambda into 1 minus p whole to the power n minus k by n minus k factorial. This is what we had. So if assuming n minus k equal to z, we'll have e to the power minus lambda p to the power k by k factorial summation z equal to 0 to infinity lambda 1 minus p whole to the power z by z factorial. So this one is essentially e to the power lambda 1 minus p, because e to the power x is summation x equal to 0 to infinity x, this will be p to p from 0 to x to the power p by p factorial. Okay, so this is by Taylor series. Alright, so here we can write it as e to the power minus lambda p to the power k by k factorial. This we'll write at e to the power lambda 1 minus p. Okay, so here we can write it as e to the power minus lambda plus lambda minus lambda p to the power k by k factorial. So we had e to the power minus lambda p to the power k by k factorial. So which is nothing but essentially a PMF of a Poisson distribution. So then marginal of x, probability x equal to k, is e to the power minus lambda p to the power k by k factorial. Therefore x follows a Poisson with mean lambda p. Okay, so now if I have to find out the marginal of y, then also we have to write it in the similar fashion. Then probability y equal to, let's say I'll write it as k prime. Okay, or we can also write k. Let us write k. So y equal to k will be how much? Again by total probability it will be n equal to 0 to infinity probability y equal to k given n equal to n into probability n equal to n by total probability. Okay, so then again here we have to write it as summation n equal to 0 to infinity y equal to k given n equal to n is nck 1 minus p to the power n minus k and p to the power 1 minus p to the power k and p to the power n minus k into again similarly to the power minus lambda to the power n by n factorial. Again if we do this, n factorial by k factorial n minus k factorial 1 minus p to the power k e to the power n minus k e to the power minus lambda to the power n minus k into lambda to the power k by n factorial. So this will cancel. This will be from k again. Okay, this here also be careful, this will be from k. because n minus k can never be negative. Okay. Fine. So here again we'll take all k terms out. So what will we do? Now we'll take out lambda 1 minus p whole to the power k out, e to the power minus lambda out, k factorial out, summation n equal to k to infinity p to the power n minus k lambda to the power, so lambda p whole to the power n minus k by n minus k factorial. So this will be again lambda into 1 minus p to the power k to the power minus lambda by k factorial into e to the power minus e to the power lambda p. So then this will be e to the power minus lambda, if we take common, then 1 minus p lambda into 1 minus p whole to the power k by k factorial. So then marginal of y probability y equal to k equals to e to the power minus lambda into 1 minus p lambda into 1 minus p whole to the power k by k factorial. So therefore y also follows Poisson with lambda 1 minus p as mean. Alright. So this is ensured. Now the next thing is this one. Find the joint PMF of x and y. Okay. So then probability x equal to I, y equal to j can be written as summation n equal to 0 to infinity probability x equal to I, y equal to j given n equal to n into probability n equal to n, again by law of total probability. Okay. Alright, so now this is done. Now we have been given x equals to y, x plus y is n. Okay, so here this thing is 0 if n is not equal to I plus j. Alright, so this thing we can write it as summation n equal to 0 to infinity probability x equal to I, y equal to j given n equal to I plus j. Okay, to probability n equal to I plus j. Okay, now this thing we can write it as summation n equal to 0 to infinity probability x equal to I. Now given x and n, so this can be written as probability x equal to I given n equal to I plus j into probability n equal to I plus j. So that we can write as I plus j given I, p to the power I, 1 minus p to the power j into e to the power minus lambda, lambda to the power I plus j by I plus j factorial. So this can be written as p to the power I 1 minus p to the power j e to the power minus lambda, lambda to the power I, lambda to the power j by I factorial j factorial. Or we can write it as e to the power minus lambda, lambda p to the power I by I factorial into e to the power minus lambda 1 minus p lambda 1 minus p to the power j by j factorial. So this can be essentially probability of x equal to I into probability of y equal to j. So then we can write it as summation over ij probability x equal to I into probability y equal to j, given that I plus j equal to n equal to 0 to infinity. Okay, so since this thing can be written as product, therefore x and y are independent. Therefore expectation of x square y square will be expectation of x square into expectation of y square, which will be variance of x plus expectation of x whole square to variance of y plus expectation of y whole square. So x follows, what did we get? Previously we got that x follows Poisson lambda p, y follows Poisson lambda 1 minus p. Therefore expectation of x square y square equals to variance of lambda p is lambda p plus lambda p whole square into lambda 1 minus p whole square. So if I write 1 minus p as q, then we'll have lambda p plus lambda square p square into lambda q plus lambda square q square. If we solve, we'll have something like this: lambda square pq plus lambda plus 1. This will be the answer. Okay. Fine. So So now we'll move on to the next one. So let x and y be two continuous random variables which are jointly distributed as follows. It's given by the PDF is cx plus 1 when x and y are greater than equal to 0 and x plus y is less than 1. Okay, the question is we have to show the range of x and y, rxy in the xy plane, to find the constant c and the marginals and this area. Okay, so how should we do it? So the first thing is to find out the range of xy in xy plane. So that is visualization. First we'll do that. All right. So we have x and y jointly distributed continuous random variables with PDF this and this, and we have to show the range of y, rxy in the xy plane. So x plus y is less than 1 and xy is greater than equal to 0. So let us have this x and this is our y. So x plus y equal to 1 is this line 1, 0, 0, 1. This line is x plus y equal to 1. Okay. Now x and y are greater than equal to 0. So this area, this entire first quadrant simply implies xy greater than equal to 0. But x plus y is less than 1. So we are talking about this shaded area. This is the range of xy. This area shaded in blue. Okay, this is the area that we are interested in. All right, this is range of x in xy plane. So this thing is done. The next thing is we have to find out the constant c. Okay, so how will we find out? We have been given that this is a one second, my pen is not working, it seems so. Fine. So now we have to find out the value of this constant c. Now since this is a PDF, minus infinity to infinity, minus infinity to infinity, fxy xy dy dx should be equal to 1. Okay, so we are going to integrate over this range, this entire range of xy. If we integrate, then we should have 1. So how are we going to do that? First, let us fix y at y. Okay, so here we have this thing, this is the range. Okay, here this line is x plus y equal to 1. Okay, so if we fix a certain y, then let us fix a certain x. Let us fix a certain x. Okay, then y can move from 0 to here 1 minus x. So then this entire thing we can write it as first y, we are fixing x at x, and y can range. Okay, we are fixing x, let's say x at x, then y can go from 0 to here it is x plus y equal to 1. So y will be 1 minus x. So y can range from 0 to 1 minus x. Okay, fxy xy dy, and then this x can range from 0 to 1. Okay, so this is the entire range integration. So it should add up to 1. Now we'll just solve 0 to 1, 0 to 1 minus x. What was the PDF? Cx plus 1. Cx plus 1 dy dx equals to 1. So this implies 0 to 1. This is integration over y. So this will come out cx plus 1 into dy 1 minus x to 0. So it will be 1 minus x dx equal to 1. So we'll have 0 to 1 cx minus cx square plus 1 minus x dx equals to 1. So then we'll have cx minus cx square plus 1 minus x 0 to 1 equals to 1. Do not forget dx. I forgot to write dx. Don't forget to write. Okay, so this will be cx square by 2 minus cx cube by 3 plus x minus x square by 2. 0 to 1, this will be 1. So c by 2 minus c by 3 plus 1 minus half equals to 1. So this implies half plus c by 6 equals to 1, which implies c by 6 equals to half, which implies c equal to 3. Alright. So we have c equals to 3. Now, what was the next question? Find the marginal PDFs fx and fy, and we have to find out this area, that y is less than 2x square. So now that we have C, we have to find out the marginal PDFs of x and y. So here fxy xy was cx plus 1. So c is 3. So 3x plus 1 when x and y are greater than equal to 0 and x plus y is less than 1. 0 otherwise. So this is the distribution. So now marginal of x, that is fxx, is minus infinity to infinity fxy xy dy. Okay, so here y will be how ranging from what to what? Y will range from 0 to 1 minus x. So we'll have 0 to 1 minus x, 3x plus 1 dy. So it will be 3x plus 1 into 1 minus x, given 0 less than x less than 1. Okay, x can range from 0 to 1 and y can range from 0 to 1 minus x. Okay, similarly, if we have to find out marginal of y, then we have to do what? We have to fix y. So same thing, fy of y will be 0 to 1 minus y, 3x plus 1 dx. So this was the range. The distribution of y is that we are fixing y. So then x can range from 0 to 1 minus y. Okay, so this will be 3x square by 2 plus x, 0 to 1 minus y. This will be 3 by 2, 1 minus y whole square plus 1 minus y. Okay, so if we want, we can solve this. Okay, we'll solve, we'll see. 3 by 2, 1 plus y square minus 2y plus 1 minus y. So then we'll have 3 by 2, 1 plus y square minus 2y. This is what? Plus 1 minus y. Plus 1 minus y. So it will be 3 by 2 plus 3 by 2y square minus 6y plus 1 minus y. This will be 3 plus 3y square so it will be plus or minus 1 minus 2y plus 1 minus y. Okay, so this will be minus 7y plus 1, so it will be 5 plus 3y square minus 14y by 2 be half. 3y square minus 14y plus 3 plus 5, sorry, it will be half 3y square minus 15y plus y plus 5 some mistake I'm making, it seems. 5 3y square minus 14y, so this will be 3y, y minus 5 plus 1 okay, some form will evolve. Okay, I think I'm doing some calculation mistake over here. This is right. Okay, 1 minus y whole square plus of 1 minus y. So whatever will come will come. Fine. So now that we have the PDFs of x and y, we have to find out the probability that y is less than 2x square. So for this one, we have to write down, we have to draw the image. Sorry, again my pen is not working. Just a second. One second. Really sorry for this malfunction. Okay. All right. So then what were we doing? We were finding out probability y less than 2x square. This is what we have to find out. Probability y less than 2x square. So again we'll draw this diagram. This is, let's say, our x-axis. This is, let's say, our y-axis. This was the area below which we were interested. We were interested in this area. Now we have to find out probability that y less than 2x square. So y equal to 2x square is a parabola. So this curve will be something like this. Here also we will have it, but we are not interested in this part. We are only interested in this part. So this will be y equal to 2x square. Okay, so y, if I have it here, y less than 2x square, then we would be interested in this shaded region. Okay, this is the region over which we should integrate the PDF in order to get the required this thing. Okay, because it is y less than 2x square. So here y is 0. This side of the curve will follow y less than 2x square. Okay, now here we have to, over this range, this shaded in violet, we have to find the, we have to integrate the joint PDF in order to get the required probability. So this one we can write as this point here, this is x equal to half. How? Y equal to 2x square and x plus y equal to 1. So x plus 2x square equal to 1. 2x square plus x minus 1 equal to 0. With midterm we have 2x square plus 2x minus x minus 1 equal to 0. 2x x plus 1 minus 1 x minus 1 equal to 0. 2x minus 1 into x plus 1 equal to 0. So this, for this intersection, it will again intersect when this goes beyond. That will be at x equal to minus 1. This is x equal to half. Okay, so this intersection point is x equal to half. Okay, So then this we can write as minus infinity to infinity minus infinity to y can go from so x can range from, so here we'll write it like this way, x can range from 0 to 1. Now depending on whether y, depending on where x is falling, y can range from 0 to minimum of 2x square or 1 minus x f xy dy dx. Okay, so if x is less than half, then y can range from 0 to 2x square. But if x is greater than half, then y can range from 0 to 1 minus x. So whichever is minimum, y can range from there to there. So this thing we'll write as, we'll break it down. When 0 to half, this will be 0 to 2x square f xy xy dy dx plus half to 1, then it will be 0 to 1 minus x f xy xy dy dx. I hope this is clear. So then once we have formulated, we are going to solve it. So this will be 0 to half, 0 to 2x square, 3x plus 1 dy dx plus half to 1 3x plus 1, we can write it like this, 0 to 1 minus x dx, sorry dy, no I'll keep parity, I'll write it in this manner. So this will be 0 to 1 minus x 3x plus 1 dy then dx. So this will be 0 to half 3x plus 1 integration of 0 to 2x square dy dx plus half to 1 3x plus 1 0 to 1 minus x dy dx. This will be 0 to half 3x plus 1 into 2x square dx plus half to 1 3x plus 1 1 minus x dx. Okay, so this will be 0 to half 3x plus 1 into 2x square dx plus half to 1 3x plus 1 1 minus x dx. 0 to half 6x cube plus 2x square dx plus half to 1 3x minus 3x square plus 1 minus x dx. This will be 0 to half 6x cube plus 2x square dx plus half to 1 2x minus 3x square plus 1 dx. So this we can write it as 6 x to the power 4 by 4 plus 2x cubed by 3, 0 to half, plus 2x square by 2 minus 3x cubed by 3 plus x. This will be half to 1. So this will be 6 half to the power 4 by 4 plus 2 half cube by 3 plus 1 minus 1 plus 1 minus half square minus half cube plus half. This is 6 by 4 into 16 plus 1 by 4 into 3 plus 1 minus 1 by 4 minus 1 plus 1 by 8 minus half. This will come up to something what? This is 3, this is 2. 3 by 2, 3 by 32, 3 by 32 plus 1 by 12 plus half minus 1/4 plus 1 by 8, something it will come to. How much will it come to? Some answer we are supposed to get. So let's see, 3 by 32 plus 1 by 12 plus half minus 1 by 4 plus 1 by 8. 3 by 32 plus 1 by 12 plus, if I do 8, it 4 minus 2 plus 1, that is 2. 3 by 8, 3 by 32 plus 1 by 12 plus 3 by 8. This will be 96. 9 plus 8 plus 12 3s are 36. We how much? 17 plus 36 by 96, 53 by 96 is the answer. Alright. So the key point to note over here is when we have y less than 2x square, when x ranges from 0 to half, the minimum of the range is minimum of these two, that is 2x square. So we'll integrate the joint probability within that range, and when we are moving from half to 1, so this is 0, this is 1, this is also 1. So and when we are moving from half to 1, then y can range from 0 to 1 minus x. This line is y equal to 1 minus x. So then we'll integrate from 0 to 1 minus x. So whenever you are giving such kind of problems, you have to break it down into intervals so that we know what the area is, where the range of x and y lies, and then we have to integrate the probability distribution function, the joint probability distribution function, over that range of x and y. Okay, this is the key point. So let us move on to the next one. So here we have, let x be a continuous random variable with PDF this. Given x, y is uniformly distributed on minus xx. Alright. Given x equal to x, random variable y is uniformly distributed on minus x and x. So now we have to find out the joint probability of x and y. So the joint probability xy is given by probability y given x into probability of x. So now y given x is 1 by 2x okay, when y ranges from minus x to x and 0 otherwise. So we'll put it here. This will be 1 by 2x into fxx is 2x, okay, when 0 less than equal to x equal to 1 and minus x less than equal to y less than equal to x and 0 otherwise. So the joint distribution of x and y is 1, 0 less than equal to x less than equal to 1, minus x less than equal to y less than equal to x, okay, 0 otherwise. So we can write it as 1 when 0 less than equal to y less than equal to mod x less than equal to 1 and 0 otherwise. Okay, this is the joint distribution of x and y. Now the next question is joint PDF we found out. We have to find out the marginal of y. So given the joint PDF, this is given by minus infinity to infinity f of xy d of x. Alright, so this one we can write it as, so the range was what? Sorry, this is 0 less than this is mod y less than equal to x, sorry, because mod y less than equal to a implies minus a less than y less than equal to a, okay. So then x ranges from how much to how much? It ranges from mod y to 1 and the joint PDF is 1 dx. So this is 1 minus mod y. And y can range from where to where? Y can range from 0 less than y. Sorry, mod y can range from 0 to 1, because that here we have less than equal to, mod y can range from 0 to 1. Okay, so this is the marginal of y. So fy of y is 1 minus mod y when mod y is less than equal to 1 and 0 otherwise. Okay, now the next question is what? The next question is find probability mod y is less than x cube. So then probability, we have to find mod y is less than x cube. This one we can write as probability mod y less than x cube given x equal to x into fx of x and integrated over the range of x. X can be from 0 to 1. X was from 0 to 1. Okay. So then mod y less than x cube given x equal to x is 0 to 1 probability minus x cube less than equal to y less than equal to x cube given x equal to x fxx dx. Now we have been given that y equal to x, y given x follows uniform minus x to x. Okay, so this thing will be minus x cube to x cube 1 by 2x into dz something into fxx dx. Okay, so then this one we can write as 0 to 1 minus x cube to x cube 1 by 2x dz into fx dx was 1 by fx was what? 1 by 2x dx. 1 by 2x or only 2x? Oh, only 2x. Sorry. 1 second. This was 2x. So here we have 0 to 1 x cube minus of minus x cube by 2x into 2x dx. 2x cancels out. We have 0 to 1 2x cube dx. So that will be 2x to the power 4 by 4, 0 to 1, that is half. Half is the answer. Okay, so the key point over here is you find out the joint distribution, then use the this is the by law of total probability. Okay, and now when condition on x, we are given the distribution. From there we can find out this probability, and then substituting this probability in the entire expression, we get the total answer. Is it okay? I hope this is okay. So if this is okay, then we'll move on to the next one. So this is also a similar kind of a thing. Let us do this one. Okay. Alright. So now let us consider the unit disk x square plus y square less than equal to 1, and suppose we choose a point xy at random at D, and the joint PDF of x and y is given by this. Then r and theta be the corresponding polar coordinates. The inverse transformation is this. Find the joint PDF of r and theta. So here also it is like same as the UV concept. So from xy we are moving to r and theta. X is given r cos theta, y is given r sin theta. Okay. So now we have to find out the derivative, sorry, the Jacobian. So sorry, here we have x equal to r cos theta, y equal to r sin theta. Okay, so the Jacobian is given by determinant of del x del r del x del theta del y del r del y del theta. So Jacobian is del old by del new. Okay, so this one we'll have as del x del r is cos theta, del x del theta is minus r sin theta, del y del r is again sin theta, and del y del theta is r cos theta. So then this will be r cos square theta minus plus r sin square theta, that is r. Therefore absolute value of Jacobian is also r. Okay, so then if we have to use this transformation, then f r theta equals to f xy in terms of r theta into the Jacobian, absolute value of Jacobian. So this will be f xy, x is how much? X is r cos theta, r, y is r sin theta, and into j. Okay, so then fxy is given as how much? 1 by pi. So this is also 1 by pi into the Jacobian, that is r. Okay, so f r theta is r by pi. Now we have to find out the range of r and theta. Okay, so r can be greater than equal to 0 and theta can be from minus pi to pi. So here we'll have theta ranging from minus pi to pi, and r can range from x square plus y square. Here we'll have x square plus y square equal to 1. So r square equal to 1. R can also, and r is greater than equal to 0. It's given. So r can be from 0 to 1. Okay. So therefore, if r theta will be r by pi, given theta belonging to minus pi to pi and r belonging to 0 to 1, and it will be 0 otherwise. Okay, this will be the joint PDF of r and theta. Okay, because we are considering this x square plus y square is less than equal to 1, r square will also be less than equal to 1, and r is greater than equal to 0, so r's range will be from 0 to 1. Alright, fine. So now Let us do this one. So let this be let x follow binomial NP. Then using Chebyshev's inequality, we have to find an upper bound on probability x greater than equal to an, where p less than alpha less than 1. Okay, so probability x greater than equal to an, we can write it as probability x minus expectation of x greater than equal to an minus expectation of x. Alright, so expectation of x will be np, so we can write it as probability x minus np is greater than equal to an minus np. Okay, we can write it like this way. Then this thing is less than equal to probability x minus np great mod of x minus np greater than equal to na minus np. Because if we have something like, let's say this is a symmetrical thing about 0, x greater than this area will be less than, if we consider modulus, then this entire region together will be this probability this is greater than something. So one-sided area is of course less than the sum of, the two-sided, the total area combined. Alright, so then this is less than this one, and now we can apply this Chebyshev's. This will be variance of x by Na minus Np by Chebyshev's inequality. So which will be equal to variance of x is Npq by Na minus Np. So when p equal to half and a equal to 3 by 4, this will be n. So then when p is half and a is equal to 3 by 4, we would have p equal to half, a equal to 3 by 4. Then we would have probability x greater than equal to 3 by 4 n less than equal to n into half by n into 3 by 4 minus n in by 2. So this will be n by 4 by 3n minus 2n by 4. So it will be this will be n by 4 by n by 4. Npq by Chebyshev's it will be by the square. So then this would be square, this is square, so we'll have n by 4 by n square by 4 square, so will be 4 by n. So this will be probability x greater than equal to 3 4 n less than equal to 4 by n. Alright. So then if we have to do the same thing with Markov's inequality, what will we do? So probability x greater than equal to an will be less than equal to expectation of x by an. This is Markov's. So then this will be np by an. So we would have equal to p by a. So we would have probability x greater than equal to 3 by 4 n equals to half by 3 by 4 just 2 by 3 less than equal to, sorry, probability x greater than equal to 3n by 4 less than equal to 2 by 3. So with that, I'm going to conclude today's session. I hope this was clear how to formulate ranges and then tackle sums which have some sort of transformations, how we can find out the marginal and conditional PDFs, PMFs, how to get the joint PDF and PMFs, and evaluate some functions of random variables. So thank you so much for your attention and time. I'll see you next week. Thank you.